Pulse code modulation, short for PCM, is used to convert analog signal to digital signal without compression. It is a standard format for digital audio used in PC, CD, and digital telephony. PCM convert analog audio to digital audio by three processes, and they are sampling, quantizing, and encoding. Sampling is a means of measuring the amplitude of an analog signal at discrete interval. For telephony, the voice signal is encoded at 8,000 samples per second, 8 bits per sample, and produce a 64 kilobit per second digital audio. For CD audio, the music is encoded at 44,100 samples per second, with 16 bits per sample. In PCM, we base on a sampling theorem called the Nyquist theorem, or Nyquist rate, to sample an analog signal. The Nyquist theorem stated that the sampling frequency must be at least 2 times of the highest modulating frequency. Comparing the two sampling is shown. When the sampling frequency is much higher than the sampling frequency, it will be able to produce a signal that is closer to the original signal. If the sampling frequency is less than 2 times of the highest frequency of the analog signal, the high-frequency information will be lost. When the sampling frequency is less than the modulating frequency, an aliased signal may be formed, and the alias signal appears to be a lower frequency than the modulating frequency. The example shown is demonstrating how an alias signal is formed. In this example, the highest frequency is 3.4 kHz. Based on Nyquist theorem, the sampling frequency must be at least twice the modulating frequency. Therefore, the minimum sampling frequency is 3.4 kHz, multiply by 2, and the answer is 6.8 kHz. The actual sampling rate used is 8 kHz. In this example, the highest frequency is 1.4 kHz, and the lowest is 30 Hz. Therefore, the bandwidth is equal to 1.4 kHz minus 30 Hz, and the answer is 370 Hz. The minimum sampling rate is twice the highest frequency, so the answer is 2.8 kHz. Quantization is a process of converting the sample voltage to the nearest standard amplitude, called the quantum level. In this example, the blue is the analog signal, and the red is the sample voltages. The sample voltage is taken at a regular interval. Quantization noise is referring to the difference between the sample voltage and the quantum levels. Using the same example, the amplitude at point 6 is 7.3 volt. It will be quantized to nearest level, which is 7 volt. Likewise, for point number 10, the sample voltage is 4.6. It will be quantized to the nearest level, which is 5 volt. What is the maximum quantization noise? It is equal to half of the step size, and the step size is the difference between one quantum level to the next level. It can be calculated by dividing the difference between the maximum voltage and the minimum voltage with the number of step minus 1. In this example, the difference between the maximum voltage and minimum voltage is 7 volt, and the number of level is 8, so the step size is equal to 1 volt. How can we reduce the quantization noise? The only way is to reduce the step size. However, by reduced step size, the number of quantization levels will increase. With more quantization levels, it will require more bits for encoding, and this will also increase the required bandwidth. So, we need to make a compromise between an acceptable transmission bandwidth and the acceptable quantization noise. In this example, The nearest quantization level for 0.16 volt is 0.2 volt. The quantization noise is equal to quantization level minus the sample voltage, and the answer is 0.04 volt. If the quantization level for the last example is double, it means that the step size will reduce by half. The new quantization level will be 0.05, 0.1, 0.15, 0.2, and so on. In this case, the nearest quantization level for 0.16 volt is 0.15 volt, and the quantization noise becomes 0.01 volt. Encoding is a process of converting the quantized level or amplitude into a digital form. The number of quantization levels is equal to 2 to a power of n-1, where n is equal to the number of bits. The following example is using a 3-bit encoding. So, the number of quantization level is 8. This is an example of a PCM using 3-bit encoding to convert an analog signal into a digital form. Thank you for watching.